Hi guys, welcome to this page of the notes, and what we're going to do is we're going to go ahead and begin taking a look at the midpoint formula. So we just looked at Pythagorean theorem and the distance formula on the previous page. We'll talk more later about how those two are related. The distance formula comes straight from the Pythagorean theorem, and I'll show you that in a later section. We'll talk more about that. This is going to be the midpoint formula. Should be familiar with the midpoint formula. Again, the midpoint, if given a line segment, the midpoint formula will allow you to find the midpoint, the center of that line segment, the point that will divide that line segment into two equal parts, right? So the midpoint formula, got a sort of definition for you right here. And again, what it's going to do, the midpoint formula will allow you to divide a line segment directly in half. Now, this section has been a lot about being able to both speak, read, and write geometry, and now we've come to the next part. Just real quick, I want to point this out for you. Whenever two segments are equal, and for now I will use the term equal, what we're going to do is we're going to use these little hash marks to show you or to tell you visually, right? This is reading geometry. You look at the diagram and you see those little hash marks, and that means segment AM is equal to segment MB. They're the same length. They have the same measure, right? That'll tell you a couple of things. First of all, that tells you that M has to be the midpoint. If M wasn't directly in the center, then these two segments wouldn't be the same. So if you're told the segments are the same measure, you know M must be the midpoint. The other way of doing this, if you're given a segment AB and you find the midpoint, you find the point M, then you know AM and MB have to be equal to each other, right? So it could go two ways. Told that they're equal, you know that M is the midpoint. If you find the midpoint, then you know AM and MB have to be equal. A couple of things about these when you have a diagram. Let's just say, for example, I add some stuff here. Sorry, that's my highlighter. Let me get my pen. If I have the point A and I have the point B, and I draw a line through those 2 points, boom, like that. And then I have another line. So right there, that is M, my midpoint. But I'm going to draw another line. Let's say I do this line. There's C, there's D, D, C. And again, I am freehanding these, so I apologize if they're not exact. I really do. I apologize. But here's the idea. If M is the midpoint of AB, line segment AB, M is directly in the middle. What you know, AM and MB are the same length. They have the same measure. And like I said, we'll use a little dash on either side to let you know, hey, that dash and that dash, that tells you that that distance and that distance, they're the same. Okay? But let's say that M is also the midpoint of CD, right? So if segment CD, M is the midpoint, you know that CM and MD are also the same length. But please be very careful here, right? I cannot use a single dash again, right? You can't use just one dash. And the reason is because I already used one dash right here. AM and MB are the same length. They're equal to each other. But that does not mean, and hopefully I've drawn this the right way so that you can tell, that does not mean that CM is also the same measure as AM and MB. In fact, CM is not the same length. So what we have to do then is, since I've already used one dash, just simply use a double dash. What that tells you, the double dash, right, tells you that CM and MD are the same measure, but they're different than AM and MB. All right, so these two segments are equal to each other. These two segments are also equal to each other, but they're not all equal to each other. Hopefully that makes perfect sense, and use as many dashes as you need to describe your figure. If I drew another line in there, and did the same thing. M was the midpoint. I would need to use 3 dashes to show you that the segments are equal to each other, but not equal to the other segments. Okay? Now, a quick note about this. I'm using the term equals, and for now, that is perfectly okay. That is acceptable sort of verbiage, terminology to use at this point. But sort of without stealing my own thunder, because I don't really want to do that, in geometry, we do not use the term equal, and here's the reason why. Let me show you. In algebra, we use the term equal in algebra like x is equal to 4. X is equal to 4. Now, here's what this means. What this is saying, all right, is that x is the same magnitude as 4, right? Means same magnitude. Okay, means same magnitude. So let's think about this for a second. If I'm measuring a distance and x is equal to 4, that means that x, whatever that unknown is, it has the same measure, the same distance, the same magnitude as 4 miles, 4 meters, 4 inches, 4 centimeters, whatever units you're using, whatever that unknown distance was, it is the same as, has the same magnitude as 4. Okay, that's in algebra. We use equal to represent equal magnitudes. Equal magnitudes. In geometry, that is not quite enough. Let me show you. What we're going to do in geometry is we're going to use this term known as congruent. Let me slide over just a little bit here. Congruent. Congruent or congruency. Congruent is the term that we will use in geometry. Okay, it's a term that we use in geometry, and we use the term congruent because it does not mean the same thing as equal. Now, for now, if you use them interchangeably, okay, that's fine. But eventually, we're going to get to the point where you understand that they do not mean the same thing. Congruent actually takes into account two things, because think about geometry for a second. Not only will you be finding if things have the same magnitude, so congruent means same magnitude. Just like in algebra, equal meant these two things have the same magnitude. Same thing here. In geometry, congruent will mean, yes, they have the same magnitude. But think about what we do in geometry. Geometry is all about figuring out the relationships between figures, between geometric shapes. So congruency has to go one step further. It's not enough to just say that they have the same magnitude. Congruency also carries with it the meaning that two objects also have the same shape. Okay, so we have this added descriptive nature kind of the term congruent. Not only does it mean that two things have the same magnitude, but in geometry, it also tells us when I tell you something is congruent, it means that they also have the same shape. And so that's the distinction and why in geometry I will say things are congruent instead of saying that things are equal. So if I go back to this diagram, what I would say then is line segment AM is congruent to line segment MB. Not only do they have the same magnitude, they also have the same shape. They're both lines. All right. So if you are comfortable at this point making that distinction, please do not any longer use the term equal. For now, I'm not going to punish you for it. It's really not that big a deal now. We'll work more on it as we go through geometry. But if you're ready to make that step and you understand the difference between the two, please, I will now be using the term congruent. You feel free. Use the term congruent, but only if things have the same magnitude and they have the same shape. That is required for congruency. Same magnitude, same shape. That is different than being equal. Okay, so here we go. Let's jump into this. The midpoint. I've got 2 points, x1, y1, x2, y2. Please notice the one to the left, x1, y1. That's just the way that I'm going to do it. Please feel free to do it that way if you would like as well. That way I don't ever get confused. Now, you'll get the same answer. You'll always get the same answer I get if you were to switch them. Order does not matter. But it helps if you do things the same way every time. x2, y2 is the point to the right. Our midpoint formula. Careful, I apologize. Let me make this quick note right here. I do have a typo right here. Please fix it if you can. Those should not be minus signs. Those should be plus signs. It is x2 plus x1, y2 plus y1. Apologize for the typo. Really sorry about that if you've got my notes with you there in front of you. Plus signs, all right? And here we go. I know you guys know how the midpoint formula works, so let's do it. This will be another example of plug and chug. Don't fat finger something on your calculator, and you're good. Now, a couple of things about midpoint and distance formula. Here's what it is. I am a huge fan, big fan, of working smarter, not harder. Please work smarter, not harder. That means find, if there's an easier way to do something, please do it the easy way. I'm going to do it the easy way. You should do it the easy way. There's no reason to make things harder than they need. There are plenty of things in life that are ridiculously hard. There's no need to make the easy things in life super, super hard. If it's easy, let it be easy. Happy with it, move on to the next thing, all right? Work smarter, not harder. Here's what I mean by that. In this particular problem, I've been told that point A is at -2. And point B is at 8. Now, those are coordinate points. This is the point, -2, 0. Oh, that's a terrible 0. And this is the point, 8, 0. Okay? Now, you certainly could, if you wanted to. Oh, hold up 1 second. It's coming. It's coming. I'm sorry. There it is. Sorry about that. You certainly could x1, y1, x2, y2, right? Plug and chug if you wanted to, but hopefully, right, what you're seeing is you recognize, hang on a second, I could just put these guys on a number line. There's -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. There's -2. There's 8. And what you can do is instead of using the midpoint formula, just count. Just count. Work smarter, not harder. If you don't have to use the midpoint formula, don't do it. Counting is easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These two things are 10 units apart. What's halfway? 10 divided by 2 is 5. 1, 2, 3, 4, boom, right there. There's my midpoint, right? Work smarter, not harder, right? I didn't even have to use the midpoint formula. In this particular case, because the points were vertical, right, I could just count. If the points are ever horizontal, you can just count. Now, if the points are not horizontal or vertical, if they're kind of at a slant somehow, if there's a slope between them, then there's no shortcut. There's no easier way. You must use the midpoint formula. And we'll take a look at that right here. But if it's simple, let it be simple. Be happy with it. Smile. Move on to the next one. It'll probably be a little trickier. Work smarter, not harder. In this case, this one was very, very easy. All right, so if you ever recognize that, please feel free to do it. If you didn't recognize that and you use the midpoint formula, you should have gotten the point 3, 0, right? The midpoint formula will work. You just may have had to have worked a little harder than the rest of us. That's okay, you'll get used to working smarter, not harder. I'll show you all that as we go through the videos, all right? Awesome, here we go, the next one. Again, I like to make the point farther to the left. My x1, y1, that's a negative. that's a positive x, so that means that this one is the one farthest to the left. This will be my x1, this will be my y1, this will be my x2, this will be my y2. These guys are not in a horizontal or a vertical line, right? These, right, if I were, in fact, here, let me show you. There's no shortcut for these ones. -1, -3, -1, -3, that's down here. 2, 3, 2, 3, that's up here. There's B, there's A. Please notice that these lines are not horizontally in line or vertically in line with each other. There's kind of that slanted line that runs between them. Guys, there's no shortcut for this. You cannot count this out to find the midpoint. Right? You can't count it out. So don't do that. Use the midpoint formula. There's really no shortcut to this one. Here we go. M is equal to x2 plus x1 over 2, comma, y2 plus y1 over 2. Guys, plug and chug, don't fat finger something on your calculator. Here we go. I have 2 plus a -1 all over 2. I have y2, which is 3, plus a -3 all over 2. M is equal to 2 minus 1 is going to be a 1, so that'll be 1 over 2, or 1/2, 1 divided by 2. In math, you don't have something over something else. It's 1 divided by 2, or 1/2. Please don't say 1 over 2. That's not the proper way of speaking the language of math. And then 3 minus 3 is 0, and 0 divided by anything is 0. So 0 divided by 2 is 0, or my point, 1/2, 0, which would be somewhere right about there. Which does. That looks very much like my midpoint. All right, so guys, that's the way the midpoint formula works. If you can, work smarter, not harder. And if you do have to use the midpoint formula, plug and chug. Don't fat finger something on your calculator, and you should be good. Head on over to the next page of notes. We'll try a few more of these. I'll meet you guys there.